So, folks, we're going to go ahead and merge now into the seminar today, first talk of the semester. And this is by myself and Jayden Engert, who's a, no, not yet, Jim. Not quite yet. Yeah, I'll wave to you. One of my PhD students here at JCU, very good student, writes beautifully. For someone at his stage, he is writing at an extremely high level. And we also have some additional co-authors, Mason Campbell, Mohammed Alamgir, and Sean Sloan are all former postdocs. Yoko, as you know, and Jamie Huther are members of my lab, administrative and research coordinators. And Saurav, hello, is a very hardcore statistician. So it's been an interesting time interacting with Saurav and learning lots of new stuff about generalized linear mixed effect models. Okay, so we'll go ahead and proceed. I think most of you know, you certainly, if you've heard me going on at length in the past, know that we're living in an era of unprecedented, explosive expansion of roads and highways and other kinds of infrastructure, water infrastructure, energy infrastructure, transportation infrastructure all over the planet. Current projections suggest that we could see something like 25 million kilometers of new paved roads by the middle part of this century, which would be enough to go around the world 600 more times. So these are legal roads and these are paved roads. So that's what the figures are suggesting in terms of road expansion, in terms of projects that are actually being legally mandated. Most of the new infrastructure expansion, this, if we think about it, probably wouldn't be terribly surprising. About 90% of the new infrastructure expansion is occurring in developing countries, which of course need development. They need economic development, they need social development, they need better transportation systems. So there's a strong and imperative need for developing nations to have better infrastructure. But the question is how does one, or can one, achieve that while also dealing with the environmental, social, and economic and other kinds of effects that can occur along with that? So anyway, most of it's happening in developing countries, and this is, again, as an example I've shown several times, the Congo Basin, the world's second largest area of tropical rainforest, an area that a lot of us think of as sort of a vast wilderness. Well, in fact, if we look at the Congo today, this is of 2007, this sort of shows you the major roads ramifying all through the Congo Basin. And in fact, even if you zoom in an area that doesn't look like it's got roads and you use high resolution methods, you see, in fact, that there's a number of logging roads, logging tracks and things like that in these areas. So there's been a paper that we published, I think last year, 2020, showed that there had been an increase by about 100,000 kilometers of new roads in the Congo Basin in the last 10 years or so. So it's incredible what's happening there. So when we talk about places like the tropics, roads and other ecosystems probably also, but in particular the tropical forest, roads have remarkably diverse environmental and economic and societal effects. And I just mentioned a few of these. I mean, roadkill, of course, we all know about. We know that roads destroy habitat. They have edge effects along the margins of the road. There's roadkill. You get incursions of hunters coming in when roads are being created. This, by the way, is an elephant in the Congo Basin that was killed by poachers. And you can tell that because it's had its face chopped off with machetes. And they do that so they can pull the trunks out, which are very valuable for their ivory. Deforestation, of course, and that's something that we're very interested in this study, but there's a clear relationship in places like the Amazon between where roads are and where forest destruction occurs. Greenhouse gas emissions, of course, we know the destruction and degradation of tropical forests is probably contributing about 15% of all human greenhouse gas emissions globally, and that's about as much as the total global transportation sector. Every car, truck, train, ship, boat, everything, plane, everything that requires fossil fuels to operate, it's equivalent to that currently in terms of deforestation and degradation. Now, something, of course, that people are talking about a lot recently is emerging pathogens. And we know also that these roads, as they're going out and opening up new frontiers and putting people into close contact, hunters and others, into close contact with wildlife, which of course carry as part of their natural biology various kinds of pathogens, which can then become zoonoses, which can infect humans. And what we've all been hearing about pangolins, that's from Congo Basin in Africa, about bats, and then primates, of course, have been another source of important pathogens, for instance, such as HIV. So that's another issue. Another thing, we could just touch on this a little bit, sort of the tip of the iceberg, but We did a literature review which published in Current Biology, led by Mohammed Alamgir, and found that there was oftentimes exaggerated economic benefits in a lot of these major infrastructure projects like hydroelectric dams and major highway projects and other things, that the proponents, the land developers and the others that were going to get a direct economic benefit of this oftentimes were substantially exaggerating the benefits that were likely to occur economically. So in fact, if you look at the project benefits, they tend to be highly variable and very context dependent. Okay, there's no universal pattern. And another thing that happens, of course, also is corruption and stolen revenues. And we see, just every developing country we look at. We can look across sub-Saharan Africa. We can look at Brazil. We could look at Indonesia. We could look at Malaysia. We're seeing that, billions of dollars of resources and revenues are being lost every year to corruption. So it's the notion that roads are good and roads are bringing positive benefits, in fact, is something I think that needs to be challenged and discussed, because again, I think the situation is highly context dependent, and there are some kinds of roads and projects that are going to be really potentially devastating in their effects. And on that note, we'll turn it over to Jayden and let him talk about ghost roads. With thongs, by the way.
They're my good presentation thongs. All right, so as Bill said, what we've been working a lot on in the Asia Pacific is digitizing unmapped roads, which we are calling ghost roads. So these ghost roads take many different forms. Usually they are illegal or unofficially constructed roads. So something like roads in a palm oil plantation, for example, are not government sanctioned. So that would be an unofficial road development that won't appear in like official road maps and things like that. You also have roads that don't fit the definition of what a government or a group might consider roads. So small like palm oil, logging tracks, things like that. Obviously, there are roads that have been constructed after the data set was developed. So if you have a data set that's 5 years old, the amount of roads that have been built in that time have all external to the data source, and you can't predict the impacts of those roads. And also roads that are too small to be mapped. So lots of the small little logging tracks and tracks on people's properties and things like that are often too small to be seen in low resolution satellite imagery, and they're often external to these data sets as well. And what all of these roads have in common is that by not being represented in data sets, they are external to conservation planning and conservation management. So we can't regulate what happens if we don't know where the impacts are occurring. So what we did was mapping all these unmapped roads across the Asia Pacific region, including Sumatra, Indonesian and Malaysian Bomeo, and Indonesian and Papuan New Guinea. And that's pretty much a picture of me for the last 2 or 3 years. So we use Google Earth imagery to draw in any roads that haven't already been mapped. And to date, we've mapped about 1.85 million square kilometers. And that has been contributed to from Laurance Lab members and 78 volunteers so far. The road mapping is an enormous challenge, especially in areas like the Asia Pacific, which have been undergoing rapid development in recent times. Road networks, are very dynamic in time. So if you look at imagery from 5 years ago, the amount of roads that have now been developed in the last 5 years is in some cases astronomical. For example, these pictures here on the left is the same location about 6 years apart. And satellite imagery programs also favor developed and industrial nations. So often we have to contend with out-of-date imagery or low resolution imagery. So if you want like good imagery of New York City, that's easy, but to try and get good quality imagery of like the rural Papua New Guinea, you're pretty much just dealing with Landsat, which is like 30-meter resolution. So if you're thinking of like a 4-meter wide long logging track, it's very hard to see. And we're finding lots and lots of unmapped roads. So these figures here, the top figure, that red line there, is the road that has been mapped already in one of the most commonly used data sets. And the figure down the bottom in yellow is all the roads that we had to digitize on top of that. So to date, we've manually digitized about 385,000 kilometers of roads in just about half of the area of the Asia Pacific that we've mapped. And that alone is about double the length of the total amount of roads in the Congo. And once we have developed these roadmaps to see sort of how the current roadmaps do at predicting impacts, we compared our data to their data. So the two most commonly used global road data sets are the GRIP data set, which is used in like human footprint mapping and things like that, and OpenStreetMap. And we found that across the different regions, on average, there was about 5.5 times as many roads as were actually included in the GRIP data set, and about twice as many roads as were included in the OpenStreetMap. However, both of those data sets are also much more biased towards urban areas. So in rural areas, the disparity is probably even larger than that. And if you look at, say, Malaysian Borneo, the difference between our data set and the GRIP data set is we have about 30 times the amount of roads. So if you can imagine that anyone trying to estimate the impacts of humans on Malaysian Borneo is probably underestimating it a fair bit. And these road data sets are used in lots of high-profile conservation studies and things like that. So we have the roadless areas, which was published in, I think, Nature or Science, the human footprint maps, all these sorts of global assessments that get published in Nature and Science and used to inform conservation policy are severely underestimating the impacts of roads. And our next question was, how closely is deforestation tied to road proximity? And we used the global forest change data, and we mapped about 2 million hectares of deforested area, and we calculated the distance for each area to the nearest road. And what we found was that throughout our areas of the Asia Pacific, about 80% of all deforestation occurred within 1 kilometer of a road, and about 38% of it occurred within 100 meters. So there's a very strong relationship between roads and deforestation. And when you compare also to the two most commonly used data sets, you find that for GRIP, for example, they only found about 40% of the deforestation occurring within 1 kilometer of a road. So in actual fact, twice as much deforestation is occurring within 1K of a road as you would expect, as you would estimate if you were using the GRIP data. And the spatial relationship between roads and forest loss varies a lot between regions. So in Malaysian Borneo again, about 95% of all deforestation is occurring within 1K of a road. However, in Papua New Guinea, it's only about 34% occurring within 1K of a road. So different histories of development in different regions also affects that relationship. And we also wanted to look at what factors promote forest loss. And this is where Saurabh was a big help to do some complex modeling here. So we used gamma GLM, and we modeled the effect of roads on forest cover, and we included 12 other covariates of forest cover. Things like slope have been shown to be related to forest cover in the past, distance to nearest city, protected area coverage, all these sorts of things. And after a lot of statistical work from Saurabh, we found that even with all of these different potential covariates, only 3 were really consistent, strong predictors of forest cover, forest loss, sorry. And that is distance to road and slope being the strongest, and rainfall also having an impact. So as you can see there, slope has a very strong relationship where flatter areas are have much more forest loss than areas that have more slope and topographical complexity. And areas that are close to roads have also experienced a lot more forest loss. And again, you can see that there's quite a difference between regions. So in New Guinea, for example, there's not a whole lot of forest loss, even in regions close to roads and on low slopes. But in Sumatra, you have a high amount of forest loss, even when there is a greater distance from roads. And we think that that's probably because regions like Sumatra are much more developed. So the only areas that are left are the high sloping sort of areas. Everything else has been cleared. Sumatra has lost about 97% of its lowland forests to date. So the only thing that separates whether a forest can remain intact or not is slope. But for all the other regions, there is a very strong relationship between road proximity and forest cover. And we also broke down the model and did a separate model for each region. And we found that in the less developed regions, that's where distance to road is the strongest explanatory factor. So if you're looking at like Indonesian Papua and Papua New Guinea and Indonesian Borneo down here, you can see the distance to road explains most of the deviance in the model. So that means that it's the thing that accounts for the model performance most. But over in Malaysian Borneo and Sumatra, where there are much more roads and it's much more developed, it's actually slope that is the biggest covariate there. I've gone through that way too quick, Bill. Do you want to cover this?
Oh, go ahead.
So the key conclusions to draw from our work is that ghost roads are abundant and a nearly universal feature of all tropical regions. And the two best global road datasets massively underestimate road density, at least in the tropics. And we found, again, that 5.5 times more road than were represented in GRIP and 2 times more road than represented in OpenStreetMap. And the inclusion of these ghost roads markedly improves the performance of models that predict the location of deforestation. There's a very strong relationship between road proximity and forest loss. And given their dramatic and dynamic effects, we direly need a way to map roads automatically. And we have Ryan Talkani working on that at the moment. And ghost roads are one of the greatest human threats to tropical forests, but are often understudied and poorly considered. Thank you.